We are going to be looking at Chapter 3, Section 4, problem number 13. In this particular problem, we are asked to find a power function that models the data below. We're going to make our calculator a bit bigger here so we can see what we're doing. The first thing that we're going to need to do is to put the data into the calculator. So I'm going to begin by going to Stat. And since I don't know what's in the calculator right now, I'm going to clear out a couple of lists. And so let me clear out list 1, comma, second, L2. So these two lists are now cleared out. Returning to Stat, we are going to Edit. In list 1, I am going to put the data from the X values, and those are simply the whole numbers 1, 2, 3, 4, 5, 6, 7, 8. So I have 1, 2 enter, 3 enter, 4 enter, 5 enter, 6 enter, 7 enter, 8 enter. In the L2 list, I'm going to put the Y values. Those are 3, 4.5, 5.8, 7, 8, 9, 10, and 10.5. And I'm not in the right place. I thought I was. Let's go back and look here. Let's edit. Okay, I got 3. I must have hit something wrong. 3, 4.5. I guess it helps to look at what's showing up on the screen instead of just looking at what you're putting in. Before I make the power regression, this last one is wrong. I put the decimal in the wrong place. Before I look at the power regression, let's take equation. Let's take a look at what this would look at as a graph. There's nothing there that's good. Let me go to Stat Plot, and we are going to plot number 1. And we want a scatter plot of this, and we do want this type of a scatter plot. We have our X list in L1, our Y list in L2, and we'll make little squares. Before I graph this, let's set up the window from, say, 0 and 9.4 is fine. This one we want to be 0. Let's make this one a bit bigger. Oh, let's make it 12.4. So I doubled the 10.2. Now if we look at a scatter plot that looks a little bit like that, it looks almost linear, but notice it has just a slight bend to it here. And because of that slight bend, a power function might be a little better than just simply a linear plot. To find the linear regression equation, the power model that fits this, we're going to go back to Stat, scroll to Calc, and now we're going to scroll down till we find the power regression. Here it is, letter A, power regression. So we're going to hit Enter. And there's other things in this line I got to start over. So I'll go back to Stat, Calc, scrolling down to power regression. And now we'll hit Enter. Now I'm going to tell it where the X list is, so that's second L1. I'm going to tell the calculator where the Y list is, that's second L2, and we'll hit Enter. This then is our power regression for this equation. Let me write that down. So if I go to my pointer options, and one more time to get a better color, let's just do it in dark blue here. This particular regression equation that we're looking at here then is we're going to have Y is equal to, our A number is about 2.98. I like to have 3 decimal places. That's going to be times X, and this is going to be raised to the B power, which is about 0.614. For the sake of just kind of completeness, let's put that regression equation into the calculator. And I want to hit y equals, so I'm going to have 2.98 x raised to the 0.614. And if we look at that graph then, we can see that this fits this then quite well. And so this then completes problem number 13 out of section 3.4.